This is lecture number 29 of the course AU203 Statistics and Quality Control. We have already started about hypothesis testing, in which we have gone through with the critical value method or rejection area method, rejection region method, or rejection area method. One of the problem with this rejection area method is we can decide about rejecting the null hypothesis, but how strongly we can reject, we cannot quantify it. So p-value method takes care of that, how strong this evidence is against rejecting H0 or fail to reject H0 when H0 is false, can be worked out using a method called p-value method. So we will talk about what is p-value, and we will perform hypothesis testing using p-value method, using the same example we have done it for critical value or rejection region method. And then we will introduce a new term called power of a hypothesis test, which is related with the errors involved in the hypothesis testing. We already have seen Minitab in the earlier lectures, so the same can be done on the Minitab as well. And in the end, we will look for hypothesis testing for a population proportion. So that is another aspect. So what is p-value is actually, it is a probability, sort of a probability, or the smallest level of significance, or a probability that allows you to make a decision about the null hypothesis based on the evidence gained through sample data. So that actually this value is p-value. We just given a name because it is actually the probability. So basically it is a measure of the strength of the evidence against the null hypothesis. So stronger the evidence, depending upon the value p-value, we can be certain about how strong evidence available in order to reject the null hypothesis or against the null hypothesis. So for example, if we come across with the smaller p-value, it means the greater the evidence against the null hypothesis. So we can say that, for example, roughly speaking, if your p-value is greater than 0.1, it means there is no evidence against H0. So if p-value lies between 0.05 and less than 0.1, then it is a moderate evidence against the null hypothesis. If p-value is small, for example, greater than 0.05 but less than greater than 0.01 but less than 0.05. So less than 0.05 means you have a strong evidence against the null hypothesis. So if your significance value is 5%, then the p-value would be 0.05. Or if p-value is much smaller, closer to 0 or less than 0.01, we can say that we have a strong evidence against the null hypothesis. So as you know, p-value is a probability, so it is on a probability distribution curve. It is actually the area under the curve of the probability distribution curve. So we can say that p-value is the smallest level of significance or a probability at which the observed value of the test statistic is significant. So the decision that has to be made based on the sample data about the decision on the parameter whether the null hypothesis is true or alternative hypothesis is true can be based on this p-value. Just take an example. We have two distinct samples, or we can think of two materials are being considered for coating a particular type of metal in order to inhibit corrosion. Specimens are obtained, and one collection is coated with material 1 and another collection is coated with and labeled with material 2. The samples taken from both population would be of same size. Let's say 10 samples have been taken, and the corrosion is measured in the percent of the surface area that has been affected. So the hypothesis is that the sample coming from the common distribution with mean is 10. So we can say that the null hypothesis and the population variance is 1. So we can say that the null hypothesis here is two populations, and the mean of the population, first population material from material 1 is mu1 and from material 2 is mu2 if it is 10. So this is your prior claim, or we call it null hypothesis. Let's say, for example, if we show the distribution of the both materials, material 1 is represented by cross, where the most of the values of the material 1 are far greater than 10, and for material 2, which is represented by circles having the mean value it is actually the 10% of the surface area that is being corroded. So it is far less than 10%. So 10 is the prior claim, and two populations, one is on the left hand side, other is on the right hand side of the distribution. So what we need is, our initial claim is that both populations belong to the same class of materials where their means are not differing. So obviously the alternative hypothesis would be that the means are not the same. So if means are the same, then it is your null hypothesis, and if means are different, then it would be called as an alternative hypothesis. So if you look the distribution from this curve, the data suggests that we can reject this null hypothesis, because this is much less than 10, this is much greater than 10, so they are not equal to 10. So from this distribution, but this decision would not be quantified. It is just by looking at the data we can make a conclusion that both materials belong to two different populations, and our prior claim that both have the same mean value of 10% surface areas is factored. That is not true, because this material, which is material 1, which is far away from the 10, and this material 2 is far less than 10. So the question is how to summarize or how to make a decision that the two means are different or the two means are identical. So both these statements can be verified, and here the p-value can help us, which is actually can be thought of as the probability, or just give you one single number, because probability always lies between 0 and 1, 0 and 1. So you end up with one number which you obtain from the given data sets, taking samples from both population. So if this p-value is much smaller, so we have sufficient evidence against the null hypothesis. Okay, now let's see what this p-value method is and what are their steps. So one thing is in contrast with the rejection area method, in which the level of significance to be the judgment of the analyst, whereas in p-value method actually the probability value or p-value is actually based upon the judgment of the analyst rather than the given significance level. So there are 5-step journey for performing hypothesis testing based on p-value method. The first 2 steps are, or rather first 3 steps are almost identical, because you need to first choose the parameter of interest or a variable, whether a mean value or whether a population proportion or a difference of mean. Whatever your parameter of interest is need to be chalked down first, and the second is need to write down the statement, 2 statements, null hypothesis and the contradictory claim, that is called as an alternative hypothesis. And then you need to choose an appropriate test statistic, which is obviously statistics is always based from the sample. and then we need to compute the p-value based on the computed value of the test statistics, and using the judgment based on the p-value and the knowledge of the scientific system, we can make a decision about whether we can reject the null hypothesis or not. So this is the steps. So I have taken the same problem which we have solved using the rejection region method or critical value method. We are doing the same problem using the p-value method. So the problem is same, that the test takers, the mean distribution is 70 and the standard deviation is 6, which is known from the history. But one particular year, the mean has dropped to 67.3, where your sample of 25 trainees were taken, and the question is exactly the same. We need to decide whether that alternative hypothesis or this null hypothesis, which one is correct. So the first step is exactly the same as the previous case. You need to define x, your variable, which is actually the marks of the trainee for a particular country, and we are assuming that this population has a mean value mu, and the variance is 6 square, which is the population distribution. The second step is to look for the same null and alternative hypothesis. So null hypothesis is obviously the trainees have performing as expected, so their mean score is 70. Or the opposite hypothesis is sometimes people use H1 or sometimes HA, whatever you use it. That is actually your alternative hypothesis. So here I missed, I called just H1, actually it is HA as I have stated here, so it should be an alternative hypothesis. Okay, so the next step is to choose an appropriate test statistic, and here we have seen that we are dealing with the single population. So there is one sample, we take it, and their sample mean becomes the test statistic, and that would be normally distributed with mean mu and variance this, and if we assume that the null hypothesis is true, then this sample mean would also be normally distributed, and its mean value would be 70 and its variance would be this based upon the sampling distribution. The test value of that statistic would be, the sample test statistic would be 67.3. Then we have to find out the Z value, which comes out to be minus 2.25. So in the fourth step, we need to compute the probability based on the test statistics. So corresponding to Z less than minus 2.25, the corresponding probability is 0.012. So this probability is actually called as p-value. So from the Z normal distribution, standard normal distribution table, you can work out corresponding to minus 2.25, which is the critical value over which the probability is 0.0122. So we can perform this test using Minitab as well. So here also we are going to get the p-value is 0.012. Where your Z score is less than minus 2.25, so the area under the curve would be 0.012. Okay, at this know that p-value is less than 0.05, which is your significance level. So 0.012 is less than 0.05. So what we can do is we can reject this null hypothesis in favor of this alternative hypothesis. So the smaller the p-value we would have, we have stronger the evidence against the null hypothesis. So the same thing we have done it here, and we have made the same conclusion using this p-value method. So we are not interested in the predefined area, and we see whether our Z statistic lying in that area or not. So here we are just computing the p-value based on the test statistics. Here the test statistic is Z. corresponding to x bar 67.3, we got this z minus 2.25, and we just computed the probability, and that would be its p-value, and this p-value comes out to be much smaller than 0.05. So we can say that we can reject this null hypothesis, and we have strong evidence that the mean value is less than the hypothesized mean, that is from 70 score. Okay, another term which is actually called as power of a hypothesis test. So the power of a hypothesis test is once again a probability of not making a type 2 error. So as you know, the probability of making a type 2 error, we represent it by Greek letter beta. So probability of making a type 2 error is actually represented by beta. So power is nothing not making the type 2 error. So probability of making the type 2 error would be probability making a type 2 error, and not making the type 2 error means 1 minus the probability making the type 2 error. That is actually called as a power of a hypothesis test. So let's say, for example, a power probability of making a type 2 error is represented by beta. So power would be equal to 1 minus beta. So power of a hypothesis test can be interpreted as the probability of correctly rejecting a false null hypothesis. So it is actually the complement of the making the probability of type 2 error, and we already have seen the type 2 error means fail to reject H0 when H0 is false. So it would be 1 minus that, so opposite of that. So here we are not we can say that the probability of making a type 2 error is fail to reject H0 when H0 is false. So 1 minus that would be actually called as probability of rejecting H0 given that the alternative hypothesis is true. So this would be called as another way of writing down the power of a hypothesis test. So I'm just using here letter power to represent the power of a hypothesis test. So either way you can represent. If you represent this way or you represent this way, it is actually the same thing. So as you know, the probability number always comes between 0 and 1. So then this power of a hypothesis test actually measures the ability of a hypothesis test to detect a false null hypothesis. So if you have the power value 1 minus beta value comes out to be near 0, it means the hypothesis is not very good at detecting a false null hypothesis. So if your power is near 0, it means 0.001 or something, then this hypothesis is considered as not a very good at detecting the false null hypothesis. So in contrast, if the power of hypothesis is close to 1, 0.9798, 0.99, then the hypothesis is extremely good at detecting a false null hypothesis. So this is actually the feature of the power of a test. So if power of a test value or 1 minus beta value comes close to 0, it means different, and if it is close to 1, it means it is different. And if you visualize everything on the one single diagram, so that would be very interesting. For example, here the hypothesized mean, which is your null hypothesis, is let's say mean value is 25. So there is a green area represents certain distribution of your null hypothesis. Your null hypothesis says that the mean value is 25. So it means if your alternative hypothesis is either your mean value is greater than 25 or less than 25 or not equal to 25. So for example, in this particular case where alternative hypothesis is that your mean value is greater than 25. So here the alternative greater than what number? The alternative value of the hypothesis would be, let's say, 30. So if this is your contradictory claim and there is certain distribution associated with that, let's say at some critical value over which you are going to reject your null hypothesis. So alpha represent the type 1 error. So it means type 1 error is rejecting the null hypothesis when it is true. So it means you have reject H naught. It means this area is representing the probability that you are going to reject H naught. So if and your H naught is that your mean is 25, but if it is greater than 25, it means you are going to reject your null hypothesis. So this area, alpha area, represents the probability that you are going to reject your null hypothesis. At the same time, this beta is actually your type 2 error, where you need to reject but you fail to reject. Then this area would be representing for this alternative hypothesis distribution. If you look at this area, yellow area, that would be representing a type 2 error. So this area is representing a type 1 error, this area is representing a type 2 error, and we have seen that there is some common area associated, and the complement of the beta, the complement of the type 2 error, it means in this area which is represented by 1 minus beta, that area is from this alternative distribution where we can reject H naught such that the alternative is true. So that area gives you the power of a hypothesis test. So depending upon the value of alpha and beta, we can find out the area under the curve, which is representing the 1 minus beta value. So how close they are, how they differ, would be representing the power of the test. So power of a test brings up certain number. If this number is close to the 0, it means because this beta 1 minus beta value could be very small. If it is very small, it means your hypothesis test is not very good at detecting a false null hypothesis, because or if it is close to 1, it means a bigger area, it means your hypothesis is extremely good at detecting a false null hypothesis. If this number is a bigger, it means both null and alternative hypothesis would be closer to each other. So it means your power of a hypothesis test is something which is extremely good at detecting the false null hypothesis. So this is actually your power of test is representing. Okay, the last thing in this hypothesis testing is we have another set of problem in which we have a drug company produce a new pain relieving drug for migraine sufferers, and its advertisement stated that the drug had a 90% success rate. So a drug company has actually come up with a new pain relieving drug for migraine. Migraine is sort of a pain in the half part of the head. And this claim advertisement of this pharmaceutical company claims that 90% is their success rate. But a doctor doubted whether the drug would be as successful as the company claimed. So he prescribed the drug for 15 of his patients, and after 6 months, 11 of these patients said that their migraine symptoms have been relieved by the drug. So out of 15, 11 claims that it is this drug is working. So what we need to do is to test that drugs companies claim at the 5% level of significance. So it means the level of significance is given, so we are free to use any method. So we are using right now this critical region method, the method which we have done in this first lecture of hypothesis testing. Second part of this question is, should the doctor continue to prescribe the drug? So we will look at later. So first go in doing the same method, but this time here we are testing the population proportion. So your status quo or your prior claim is that your particular drug has a success rate of 90%. So it means out of every 10 patients, 9 actually relieved by that drug. So this is actually the prior claim from the pharmaceutical company. So what you need is first step is once again the same. We have 7-step journey for critical region method. So we have to identify the random variable, which is actually the number of patients whose symptoms have been relieved by that drug. So that number could be 12, that number could be 14, could be 15. So there are maximum 15 samples have been taken. So assuming that the effect of the drug on each patient is independent of each other. So it means whether the particular drug has been effective on a one particular patient or second patient or third patient. So they are not involved. So these are independent random variables. As you see here, the number of variables involved is actually a discrete variables. So it could be 5 patients, it could be 6 patients, it could not be 5.5 patients or 5.7 patients. So here it means you are dealing with the population proportion. So here you are dealing with the discrete random variable. So we are assuming that X is binomially distributed with the 2 parameters. The first parameter is the sample size and N and P. N is the sample size and P is the probability of success. So here the probability of success is not known, but the sample size is known. Okay, the second step is to state the null and alternative hypothesis. So null hypothesis is always some equality. So here the P is the parameter of interest, which is a population proportion, and 0.9 means the success rate of the drug is 90. So here doctor claims that the success rate is not 90, it is much on the higher side. So doctor doubted that it should be less than 90. So here the alternative hypothesis is what the doctor is doubting, which is less than 90%. So these are the two statements which we must have to put forward in hypothesis testing. In the third step, we need to find out the distribution over which the null hypothesis is based upon. So if null hypothesis is true, then it is going to follow a binomial distribution, and then your success rate would be 90% if your null hypothesis is true. Then the state, the level and the type of the test. So their alternative hypothesis is HA is such that the population proportion is less than 90%. So we need to look for this region in which the lower tail of the distribution, so it becomes a one-tailed test, because we are interested in the proportion which this drug is not successful is less than 90%. Okay, in the fifth step, we need to identify the rejection criteria. Here, the rejection criteria is that your every random variable would be less than, its probability is less than 5%. So we can reject the null hypothesis. So the next step is to calculate the required probability. The test value is not the mean value, but the number of patients which actually relieved by the drug is out of 15, 11 patients have been relieved by the drug. So we need to find the probability that your random variable be less than 11 or equal to 11. So it means less than 11 means 1 minus probability X is greater than 11. So greater than 11 means 12, 13, 14. So 12, 13, 14 and 15 are all added together to get the probability of a random variable which is less than 11. So we can see on this Minitab as well the distribution for a sample size of 15 and a probability of success is 0.9. So we know in binomial distribution, when your probability of success is other than 0.5, then you have skewed distribution. So it is a left skewed distribution. If your probability is greater than 0.5, if this is less than 0.5, then it is this sort of distribution, which is rightly skewed distribution. And when probability of success is zero point 0.5, then you have a uniform distribution. We have already seen in this lecture of binomial distribution. So what I do is here we calculate the test the probability, and your hypothesized proportion defective is 0.9 versus less than 0.9. Here you are taking a sample 11, x your random variable is 11, and n is your sample size, and your sample proportion comes out to be 0.733, and its p-value additionally coming out to be because 0.056. So as we already have seen that this sample proportion coming for this would be 0.733. So it means we have evaluated probability for this test statistic would be 0.056. So which is the 5.56% area. So which is much greater than 5%. So here we are failed to reject the null hypothesis. Null hypothesis, hence the drugs company claim is upheld, because we don't have sufficient evidence available. If your p-value, if you look at the p-value also, your p-value must be, in order to have a strong evidence against the null hypothesis, your p-value would be much smaller than 0.05. So here the p-value comes out to be 0.056. It means you cannot reject your null hypothesis. So it means you need to support, you need to favor this alternative hypothesis. You are failed to reject your null hypothesis, so it means your alternative hypothesis is, so it means it has a 90%, at least 90% success rate. So this is how we need to solve a problem related with hypothesis testing. Okay, so we see in the last part we need to find out should the doctor continue to prescribe the drug, because it is become effective. So we have seen that the p-value is greater than 0.05, but it is very much slightly greater than 0.05. So as a caution, we can suggest that it is not very strong value, which is not much greater than 0.05. So the doctor is not actually, as a caution, not going to suggest this drug, because the sample suggests 11, or if it is just to do the same problem when your value is 12 or 13, then probably you have the p-value comes out to be much greater than 0.05. So it means we cannot say that it is so strong. So this is how the p-value is useful when you're talking about whether it is stronger or less stronger. Okay, now let's see how to do it on this Minitab. Let's say how to do the same problem using Minitab. Just go to this stats bar, basic statistics, and then go here in the bottom here in this one proportion. So here you are determine whether the proportion of an event observed in a sample differs significantly from a specified value. So if I just click on that, so here I have some two possibilities, whether we have data in this column or whether we have a summarized data. Let's say I have summarized data, then number of successful events in which the drug effective it is 11, and total number of trials is 15. And if you just click on that, perform hypothesis test, your hypothesis proportion is 0.9, and you need to go into this because your significance level was 5%, so the confidence level comes out to be 95%, and your population proportion, because it's a one tail test, left tail test, so the population proportion should be less than hypothesized proportions, and we will use an exact method to do this. So once I click on that, I will be able to see the result test for this population proportion, where p-value is 0.9, which is your null hypothesis, versus Alternative hypothesis is what doctors wishes or researcher wishes to investigate, which is less than zero point 0.9. So here we have a sample size of 11 samples have been taken, or 15 samples have been taken, and the probability of success is we know zero point 0.9, and 11 is the number which actually got, so 11 by 15 means 0.733. So that would be your sample proportion or percentage of the sample proportion. And if you see here, the p-value is estimated to be 0.056. So this p-value is slightly greater than 0.056. It means here we are not going to reject the null hypothesis. We need to consider the alternative hypothesis that this is we cannot reject actually null hypothesis. So this is the conclusion we have drawn, and this is a test for one sample test for a proportion, and we can use that. So here this area rejection method, so area also can be worked out using this probability graph, and this is how we have to do it on a Minitab. So this is where I end this lecture.